Heavenly Father, we come to you today asking for your guidance, wisdom, and support as we begin this meeting. Help us to engage in a meaningful discussion. Help our friends who are not yet on a call to join, and also help us that we may have a good network such that we can be able to learn, and whatever we shall be learning in this session, help us to be able to apply, and we appreciate agriculture. We make this through Christ our Lord. Amen. Let me hope everyone can be able to hear me. Kindly, you can unmute and just say hi in case you are able to hear me well.
Hi. Hello, hi, I'm Kabali Edward.
Okay, perfect.
Hi, I can get it.
Okay, good. Okay, thank you. Allow me to share my screen. And we get started. So on my first screen, I'm sharing just a few photos of a simple garden. We have a greenhouse and we have a simple garden having some few crops. And my assumption is that at least everyone on the call, you can be in position, or you can be able to set up a simple garden at home where you can have these vegetables. Now, today in our session, our main focus is coding in agriculture. That's why we are here. And my name is Stephen Kaziba. And what is our agenda? This program is going to have sessions the whole of this week and next week. We are going to have a number of lessons sensitizing you on how we can do the coding in agriculture. It may be a new knowledge to many of you. That's why our first lesson is going to focus on the knowledge of coding. You may not, some of you may have heard about coding, but you may not have that knowledge. You may have limited knowledge, and you may want to learn more on what coding is in agriculture. So we shall be able to understand the difference between coding and programming. That is going to be the first lesson, and that's going to happen today. Then our next lesson, tomorrow, 5th, we shall have understanding the basic concepts. So we shall look at algorithms, data mining, big data, predictive analytics. That will be our second lesson, and we shall be sharing with you all the work that we shall be discussing throughout the lessons. Then we shall have the third domain, which is the wisdom. That will be the coding level 1, and this will happen on Wednesday. And then on the Thursday, we shall have empowerment, which is the coding level 2. So that will be on Thursday. Then on Friday, we shall move on to the other level, which is the capacity, which is called, which is level 3. Each of these levels, I'm very sure there is something you're going to learn, and there is a lot that each one of us must learn as we move this journey together. Even if you have no knowledge on what coding is, I want to let you know that by the time we shall have all these lessons completed, you'll have learned a lot when it comes to coding in agriculture. You are going to learn what is the importance of coding in agriculture. And what is our goal? Our goal in this course is to enhance youth participation in agriculture for enhanced productivity and profitability using technology. There is a lot technology can do. So as a teacher, as a student, because here we have both students and teachers, there is a lot that you can use this technology to solve a lot of complex problems, and also to be able to do your work easily without using a lot of knowledge, but when you're working very smart. Then our purpose, the purpose is to have a mindset change. from negative to a favorable perception of agriculture. If you look at statistics, you can notice that few of our children in this country go on to take on agriculture. But why? It's just because of the mindset. But I want to let you know that I personally am not an agriculture teacher, but I'm a mathematics physics teacher. But because I have the right mindset, I do believe that once I know agriculture, I can be able to teach any other subject that can come on my way. So we want to have a right mindset such that everyone can be able to take on agriculture. You may not take it theoretically in class, but you can be able to practice it and do it using the technology, because the world now is evolving around technology. The person who will be able to use technology will be able to earn more and will be able to do a lot of work than someone who's using the other rudimentary methods. So the learning objectives. By the end of this course, what are we expecting to have learned? One, to increase the youth knowledge of coding in agriculture. That is our first objective. Then to learn how to use algorithms of problem solving and optimizations. And then 3, to provide hands-on experience in managing agricultural data using technology. So the third objective is going to be a physical interaction. We shall meet in Gayaza for the physical interaction, such that even we can have a hands-on on how we shall be interacting with the different innovations at code level 5. So the third objective is going to be achieved when we meet physically for a face-to-face session, which will happen on Tuesday of 12th at Gayaza. And that's when even we shall have what we call the mad mobile phone gaming. So that will be our last session, which will be coding level 5, which will happen on Tuesday of the 12th, that is next week. Then the learning outcomes: increased knowledge of coding in agriculture, specifically in soil testing. Soil testing is important. Before you put any crop in the soil, you need first to come out with a test and find out whether the crop you are putting on that given soil will come out very well. We have found out that very many farmers go on to lose their money, to lose on their crops, because they do not test the kind of soil. So for them, they think that any kind of soil can favor the given crop. However, it may not be true. You may need first test, and we shall show you how are we going to test using this kind of knowledge. Then also improved understanding of the different concepts of coding. So that is briefly what we are going to be looking at in this course. So this course is going to be very, very important for both the students and the teachers. And through this knowledge, we shall be able to apply it in other fields, not only in agriculture, but we shall transfer the knowledge from agriculture coding to mathematics, to physics, to geography, or to any other field that you are dealing in. So this knowledge is going to be very, very important. So that is briefly what we are going to be looking at in this course of ours. However, how is the course going to move? And who is that person? Who is our teacher, or who is our facilitator? So through this course, our facilitator is none other than Professor Tenywa Moses. And Professor Tenywa Moses is the person who is going to be taking us through this course. Professor Tenywa is the director of Light Open and Branded University, which we abbreviate as LOB. But do you know a brief background? We can have a brief background about who Professor Tenywa is. So Professor Tenywa holds a PhD in Soil and Water Management from the Ohio State University, that is USA. So he's very well conversant with the field of soil and water management, and is going to be our facilitator. Professor is a former professor at Mackay University and has been the director of the Mackay University Agricultural Institute. which we know as Cavagnol. Many of the teachers on the call are a bit sure you have ever taken your students to Cavagnol. And I'm very sure some of you might have been ever interacted with Professor. So he's the person who has been behind Cavagnol. All the developments around Cavagnol is the person who has been behind that. Is a director of Light Open and Braden University. This is the university that the professor has started that is about agricultural innovation systems. So maybe even by the end of this session, many of you even can go on and join the university such that you can be able to learn more on what you call agricultural innovations and also others. He has served as an education specialist in agriculture and also at the board of the Commonwealth of Learning. He has supervised over 10 PhD students. PhD is one of the highest ranks in the academia, in that academic field. So he has supervised over 10 students and over 25 master students. And the professor has over 50 publications at the international level. So this is the person that is going to be taking us. Professor also serves on several international editorial bodies, including Journals of Soil and Tillage Research, and is a member of the editorial advisory board of the Encyclopedia of Soil Science. So Professor was also recognized in 2006 as one of the, because of the soil test kit that the professor and his team were able to invent. These are a few things about Professor, but he has a big profile that we have not been able to bring for you. So he's a person who is going to be taking us through everything in this course of coding. In case you have any questions, always you are going to feel free to ask. Still, we are going to be using two channels. We shall be using the Zoom for our lessons, but also we are going to be using the Google Classroom for the notes. So all the notes, the PowerPoints, and any questions you may have, even the tests that we shall be trying out, will be accessed through the Google Classroom. So we are going to be sharing a link in our, we are going to be sharing a link, and we shall be asking everyone to just click on that link such that you can self-enroll yourself into that course. And after enrolling, you'll be able to receive any updates that we shall be having. So all the notes, those who have already enrolled into the course, thank you so much. And those who have not yet, we are going to post the link here such that at least you can be able to enroll yourself into that course. So we shall be using the both channels such that we can be able to move together. Otherwise, I want to thank everyone that has joined this call, everyone that is here to learn. Thank you so much for sparing your time to be with us. So now in the chat, I'm just posting a link. So that link I'm posting is the link to the Google Classroom. So those who have not yet joined that classroom, just click on that link and then you can be able to join that classroom. Then any other thing that we put announcements, notes, and everything will be accessed through that link. Even the recording for this session, those who have been asking for the recording, we shall have the recording on that link. So allow me now to invite Professor to start the presentation. Professor, you're most welcome.
Thank you very much. And I wish to thank you for the able introduction that you have made for the class, preparing them for the training. Today we are going to start our first lesson, which is knowledge on coding. And so I'm going to share the screen. All of you are able to see the screen?
Yes, Professor, we can see it from our side.
Okay, so I will be tackling lesson 1, which is knowledge of coding. The outline of the presentation will be an introduction, definition of coding, what kind of questions are answered by coding, then coding in action, benefits of coding, principles and practice of coding, and I will end with some acknowledgements. Coding in agriculture increases efficiency in resource utilization on the farm through improved management of the processes. Meaning if you're a farmer, you will get more benefits, more yields, more income than somebody who is not involved in coding. It is premised on functional algorithms that analyze, recognize patterns and trends, and order things to solve problems or optimize resources. It is driven by data captured from farmers' boundary practices using different devices such as a camera, and these cameras can also be mounted on drones. Then we can also use sensors to be able to capture data on soil moisture, temperature, relative humidity, and all other parameters that are necessary in establishing the functions of plant growth and the yields. Coding is not something that is new because it is used in everything that we do in life. Actually, one can say God has coded human beings. So everything is actually coded. Coding is a subset of programming. Coding in agriculture is a way of making technology shake hands with agriculture. Meaning to a great extent in the past, much of the work in agriculture has been of drudgery, laborious, using hands. But in coding, that's where we get an opportunity to make technology shake hands with agriculture, meaning we can get technology to help us implement activities in agriculture. Coding is both an art and a science of linking devices, computer, mobile phone, tablet, camera, drone, to agriculture. It is actually the key to transitioning into the digital world or digital economy. Coding is often interchangeably used with programming. They almost mean the same thing, but as I mentioned, that programming is broader. It may undertake several processes, whereas coding can be able to be stopped at a certain point, as long as you can get the solution to the problem that you have. Coding uses codified knowledge that can be written down, whereas coding cannot capture tacit knowledge. There is a difference between codified knowledge and tacit knowledge. Codified knowledge is the knowledge that one is able to write down. For example, if one is preparing breakfast, can be able to say, you can write down that you light the fire, then you put water in a kettle, and then you boil it and all of that. But there's some knowledge or skills that one can be able to use as a human being that cannot be written down. That's what we call tacit knowledge. So that means coding has a limitation whereby in some cases a human being must come in and bring their knowledge. And so where a human intervention or human agency is required, that is where tacit knowledge is that cannot be codified. Now, what is the definition of coding? There are several definitions of coding, and so I've provided all of these definitions of coding to enable you have a better understanding, or rather better knowledge of what coding is. Some people prefer to define coding as a set of rules that precisely define a sequence of operations. Others refer to it as a process of systematically writing a mathematical function or algorithm consisting of step-by-step instruction that a device such as a computer can understand and execute to solve a problem. Others refer to it as a simple cookbook or a prescribed bureaucratic procedure or a computer program that stops. Others refer to coding as the fuel for the computing power that is needed to perform tasks, meaning that it is the fuel or what powers the computer to be able to do tasks, say, in agriculture. Others refer to it as a procedure or a formula for solving a problem based on carrying out a sequence of specified actions. Coding can also be referred to as a procedure that solves a recurring problem through repetition by carrying out several finite steps, whereas others refer to coding as a procedure for optimizing resources in achieving a goal. So, as you can see, coding is a way of powering the technology to be able to undertake activities in agriculture. And it involves describing or writing down precisely those steps. So, what are some of the questions that are answered by coding? One of the questions that can be answered by coding is, how can technology be used to improve agriculture? As many of you know, and this program, we are targeting many of the youth because many of the youth do not want to go into agriculture because it is laborious, it has drudgery, and all of that. But if technology is available, then you can get more youth involved in agriculture. That's why coding is important in helping to improve agriculture. What makes devices smarter than humans in farming? It is coding. Because as you know, if you have like a farm manager or you are yourself the farm manager, you will have so many husband practices that have to be managed and a lot of inputs, planning, a lot of data analytics that are required and all of that. And so sometimes you may forget something or something may lapse through. But when you have a code or an algorithm and you are using that to manage, then that explains why technology is smarter than human is, because you've done thorough coding. Another question that can be answered by coding is, how can the problem of low productivity and profitability be solved? Another question is, how can resources on the farm be optimized? Again, we use technology, but we do coding to facilitate the technology to do the optimization of the resources. I've time and again mentioned how it ameliorates human drudgery on the farm, and also how can farm operations be implemented effectively and efficiently. That is again also by coding the technology. Now, coding in action. How can we really gain some increased knowledge regarding coding? What can we be able to talk about? Coding in agriculture can be done in practical and simple ways by providing hands experience, as we shall be doing. Stephen has explained that on the 12th. But some examples are analyzing agricultural data. Coding can be done to analyze soil, crop, weather data, using even simple tools like Microsoft Excel and Google Sheets. Also applying basic concepts of Python, give variables, loops, conditional statements, syntax, and operators to problems in agriculture, such as calculation of yields. Also learning to program microcontrollers connected to sensors for monitoring soil moisture, temperature, relative humidity, and controlling the irrigation system. So coding can be done so that when a sensor, for example, that is put in the soil to determine the soil moisture, establishes that the moisture has dropped below the threshold, then the microcontroller can trigger the irrigation system to begin watering, so that it doesn't require a human being to be there to monitor that the moisture content has dropped, but you can use technology and be able to determine when to irrigate. Also, web development for farmers to access agricultural information using tools such as HTML, CSS, JavaScript, and very importantly, mobile app development using tools like App Inventor, Swift for farmers to access real-time information about crops, markets, and weather. So you can see that coding is a big thing in many of the activities that we have on the farm. So what are the benefits of coding? Coding enables farmers to leverage technology and data to optimize various processes, such as soil testing. In soil testing, we have many challenges. For example, identifying the soil units where you will take the samples. And if you are to take many samples, then it becomes costly. So we would like to minimize the samples, but do it optimally so that we know that the soil test actually gives good results. And so for such, coding can be very, very helpful where we leverage technology, the same as in planting, fertilization, weeding, spraying, and harvesting. And for each of these, you'll have different algorithms and different technologies or devices that are used to implement them. Another benefit of coding is that it can help automate tasks, like I mentioned before, irrigation. It can improve efficiency, and it can aid in decision-making in agriculture based on the data input that you have. And very importantly, it can lead to youth empowerment through job creation and self-employment, as well as contribute to national development. There are principles that govern the practice of coding. For example, you don't just go in coding. Coding is done with a purpose, and that is to solve a problem. So one of the first principles is that you must identify a problem. And this is done to establish a specific problem or challenge to be addressed through coding and software solution. The examples include crop monitoring for pests, diseases, and nutrient deficiencies, irrigation management, livestock tracking, yield prediction, optimization of supply chain. Another principle is the needs assessment. Once you have identified the problem, it is important to gather the relevant data from the stakeholders so that you establish the requirement for coding, so that your coding will be useful to the farmers, the agronomists, to the researchers. So Some of the information that you have to search out is functional requirements, non-functional requirements, the use case for each of the stakeholders, and the context of the problem. That means, as a matter of principle, you need to prepare very well ahead before doing the coding if it is going to be beneficial. Then another aspect is actually mapping the software solution. In a way, creating a roadmap, designing the software solution. Some of you may be familiar who have done some bit of programming that you can develop a flow chart that details the different steps that you are going to use in terms of developing the code or software solution. And in developing this one, there are issues that you have to take into consideration, such as scalability, modularity, and usability. And also you have to identify an appropriate architecture, data models for the agricultural system that you are addressing. Then also integration of existing data sources, because as you know, it's very expensive to collect data. So as a matter of principle, try and use available quality data, then you can supplement it with extra primary data. But if there is secondary data, then it's a good practice to also use that one. So if you do not have all the data, then there is also use of the sensors to collect real-time data for analysis. And again, codes have to be developed so that what the sensors sense, the variables, that information can be transmitted in a manner that your device can be able to interpret and make solutions. Now we come to the actual programming or writing a code to execute the software solution. This one using suitable programming language like Python and frameworks. So examples include developing a web or mobile applications, data analytics, algorithm, machine learning to help train the devices to be able to operate like human beings in addressing some of the problems. Another principle and practice is data management. You have to identify very good strategies for data collection, storage, and analysis. I believe this is the heart of coding, and the considerations are designing and implementing databases, data warehouses. What are your data sources? These must be able to provide quality data, because if you provide garbage, then even the output will be garbage. So as a matter of principle, you must ensure that you have quality data. As you know, data is very sensitive. You have to take into consideration data privacy and security to avoid legal implications. Quality management. Quality management is very, very important. It is very useful to ensure there is quality control, and this must be planned thoroughly so that you can be able to perform thorough testing of the software solution, to identify and fix bugs if there are errors and other issues, so that your code actually delivers to the expectation. And so you have to conduct unit tests, integration tests, system tests, continuous integration, and deployment to ensure software solution is optimized. Another principle is, as much as possible, create an intuitive and user-friendly interface to ensure access to farmers and stakeholders. So as I mentioned, that coding is both an art and science. I think this is where you really tap on the God-given art potential, your art of making the interface friendly to the users of the app for which you are powering the technology to solve a problem in agriculture. And some of the things you consider is the language, the device compatibility, ease of use, and connectivity. All of those are paramount to ensure that coding is beneficial to your stakeholders and it delivers to the expectation. Now we come to the documentation of the software solution. This includes its design, functionality, and usage instruction. As you know, when you buy any equipment, you must have kind of a booklet that describes exactly how the equipment operates, an operator's manual. In the same way for the code, it is important to document its design, functionality, and usage instructions for those who are going to use it, the stakeholders. And that must be clear and concise documentation, as well as be able to provide the user the necessary support to operate. As you realize, coding is almost a life process. It requires collaboration from multidisciplinary teams if it is to work. So you have to work with software developers, agriculture experts, farmers, end users, stakeholders for continuous improvement, especially if you are addressing a complex problem. And so you have to do some kind of intellectual, social capital development. There's need also to maintain and support regularly the software solution by fixing bugs, performance optimization, and updates so that you are able to deliver to the expectation. I think that marks the end of my presentation, which was aimed at increasing your knowledge of coding. And I wish to take this opportunity to acknowledge the Commonwealth of Learning, the government of Uganda through its Board of National Council of Higher Education, local government of Wakiso District, the Board of Directors, Light Open and Blended University, the members of Lob University Council, members of Truth Bible Church. I want also to acknowledge the support of Mr. Ronald Dungu and Mr. Stephen Kaziba. So that ends my presentation. I want to hand over back to Mr. Stephen Kaziba.
Thank you so much, Professor, for that wonderful presentation. I know some members came in a bit late and some may have some few questions. So in case you have any question, based on what the professors presented, and maybe you may need some more clarification, kindly raise up your hand. Those who are new to Zoom, you can check down there where you have the icons in case you're using a laptop and a phone, check on the reactions and you can raise others. You can just use the chat and then you type in your message in case there's any question that maybe you want the professor to clarify. So I'm seeing Peace. Peace, do you have a question? Someone is asking, okay, Redeemer will begin at exactly 2 p.m. and we shall be sharing the recording. We shall be sharing the recording after this session. Okay. So members, do we have any questions? Okay. Yes, Mr. Matthew.
When will the lessons be starting?
Okay. Going forward, we shall be starting at exactly 2 p.m. Okay. Okay. So, okay, I think, let me just check the chat. Okay, so let me share the link to the Google Classroom where you're going to find the recording and where you're going to be find the notes such that you can be able to go through. So I want to thank everyone that has joined this call. So we are going to have these sessions up to next week, but we shall have the physical interaction, which will happen on Tuesday. And that physical interaction, everyone will be able to have a hands-on for you to work out. So you make up your plans and prepare for Tuesday of next week, where we shall be meeting in Gayaza. So for the teachers, prepare, we shall be in Gayaza, and also the students prepare, start talking to your parents about that physical interaction that we shall have at Gayaza. Once again, allow me to thank Professor Moses for the wonderful presentation. Thank you so much, Professor, for taking us through on what coding is, the kinds of problems it can solve. Yes, thank you so much. And I also want to thank all the teachers and the students that have joined this session. Thank you so much.
Thank you very much. Yes.
Okay. So we are going to end here unless you have a question, but since everyone is okay, let us start from there tomorrow. Let me wish you a good afternoon. Bye-bye, everyone.